Hi, my name is Dr. Jennifer Wenner. I teach mineralogy at the University of Wisconsin-Oshkosh. And today I'm going to talk to you a little bit about the biaxial indicatrix and how that is constructed and how it affects what we see in minerals. So the biaxial indicatrix, first of all, the indicatrix is an imaginary 3D object that describes the way that light behaves in minerals. The biaxial indicatrix is defined by three unique axes. And we can construct the biaxial indicatrix using tinker toys. Some of you may know these. These are little wooden rods and connectors. And to construct a biaxial indicatrix, we need three different colored tinker toys, a short one, which is the yellow here, an intermediate one, which is the blue one here, and a long one, which is the green one. So three unique axes, three different length axes, which represent the indices of refraction that light sees as it goes through the mineral. Now, if we were to connect this into a three-dimensional object, we would get something that looks like a potato. And a potato is a really good way to illustrate how the biaxial indicatrix is constructed. You can see that there are three different axes here, and I'm gonna mark them with a skewer since I have skewers. When we use these, in this particular instance, yellow's short, blue's intermediate, green's long, we're gonna do the same thing here. The short axis is here. We're looking at it this way, it's going this way. And I'm gonna put a skewer through here that is marked with A or alpha. The short axis is always called A or alpha, okay? And it goes like that. The intermediate axis is B or beta, and it's gonna go through like this. Hopefully it will go through the right way. Yep, there we go. So there's beta, that's the intermediate axis, the blue one. And the green one is gonna go through, this one's hard to get through, to come out there maybe. Okay, so sort of, it's not exactly right on, but it's through the long axis. Oops, and that's supposed to be green, there's the green one. And that is C or gamma. Okay, so gamma or C. Okay, so we've got long, short, intermediate. Okay, now when you have a triaxial ellipsoid like this, that's what that's called when there's three of them, triaxial ellipsoid. There are lots of different ways that you could slice this. And a slice is what we're gonna see when we look in thin section, and the difference in the size of the axes determines the birefringence. So I'm gonna set this one down for a minute. We're gonna come back to this one momentarily. But I've got a couple of different potatoes here, different sizes. We can slice the potato parallel to the long axis and the short axis. And if we do that, we'll get an ellipse that has very different sized axes, a very long one and a short one. This particular slice would give us a very high birefringence, and we would see high interference colors in cross polars in the microscope. We could also cut the potato, let's say, parallel to the A and B axis, or the alpha and beta axis, and we get something that's a much smaller ellipsoid. It's still an ellipse, excuse me. It's an ellipse when it's only 2 dimensions. We get a much smaller ellipse. That ellipse is gonna have the two axes perpendicular to one another are gonna be close to each other, and therefore you're gonna get a lower birefringence, not the lowest, but a lower birefringence. Okay, we could also cut it at some random angle. So I'm gonna cut this one at a random angle, and we get something in between the long and the short. It always goes through the middle, so we always get the intermediate axis, but there's gonna be something that's between the intermediate and the short, or the long and the short, or the long and the intermediate, there. So we get, here's a big one, high birefringence, small one, low birefringence, moderate birefringence. Okay, those are the potatoes. Now, what about the circular section? Because the circular section is a very important slice that goes through all indicatrices. And if we take this triaxial ellipsoid or biaxial indicatrix, I'm going to take these out of here, but we're going to keep in mind what the sizes of these are. You need a ruler to do this with your potato, okay? In order to figure out, well, first of all, let's do this. If I look at this, technically there are two ways that I could cut this potato to make a circle, to make a perfectly circular home fry. There are two ways to do that. I'm going to show you how we can figure that out. It's essentially geometry. If we know the lengths of the axes, so if I take my ruler and I'm going to eyeball it, I'm going to see what the long axis is. And if I eyeball this, the long axis is about 9.5 centimeters. Okay. Now this is the intermediate axis, and I'm going to measure that like this, and it's about 5 centimeters. So it's 5 centimeters that way. And then I'm going to turn it this way, and I'm going to measure like that, and it's about 4 centimeters. Okay. If we look at this, we have a long axis, an intermediate axis, and a short axis. Between the long axis and the intermediate axis, we could cut it in a variety of ways, and one of the axes of that particular slice would be between the intermediate and the long axis. We could do the same thing anywhere around here. We could cut, as long as we cut through the center. But there are two places where along this ellipse we can have a length that is equal to the radius of the intermediate axis. Okay, so this is intermediate. We're looking at the long and the short axis here. All right, we know that the intermediate axis is 5 centimeters. That means across. So the diameter is 2.5 centimeters. If I want to figure that out, I can take my ruler, I can line up 2.5 with the center of this side of the, with the center of the short axis. And I can rotate my ruler until both sides intersect, one at 5 and one at 0. And if I do that, I can take my marker, I'm going to take the green one, and I'm going to make a line right along where that is. And we'll do it the other way too, because there's two ways you can do it. So I'm going to line up 2.5, and I'm going to rotate it until 5 and 0 intersect, which is somewhere like right in there maybe. And see, I've got an X there. If I cut along one of those lines, I should get a circle. And we're going to try it. I'm not always successful at this, but I try. So we're going to cut right through there. Is it a circle? It's not quite a circle. It's a little bit elongated, but we're close. Because there are two places where you can slice it into a circular section, the optic axis is always a pole to the circular section. It's a it's the pole to the circular section. So this means that there are two optic axes in the biaxial indicatrix, which means you can slice your mineral in two different ways and get the same diameter in the indicatrix. Okay, so two optic axes, hence it's called biaxial.